Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about rank of a matrix. This is very important class to understand. We are going to give you so much intuition about how we are going to use this rank of matrix in identifying some concepts. So please watch this class till the end and watch it multiple times until you get the clarity. So before we move on to this rank of a matrix, in our previous classes we already done some examples on a row echelon form. You take a matrix. This is the matrix 1, 1, 2, 2, minus 1, 3, 3, minus 1, minus 1. So we are going to apply some row operations and we are converting this matrix into row echelon form. So we are trying to eliminate these elements. We are trying to make these elements, the lower triangle elements, see these elements. We are trying to make them as zeros. So the same example in our last class example, after converting this matrix into row echelon form, this is what the output we got. 1, 0, 0, 1, minus 3, 0, 2, minus 1, minus 17. And we have said that this 1, minus 3, minus 17, we call them as pivot elements. Now first we need to understand what is meant by pivot element. Which one we call them as pivot elements. After applying row echelon form, means after converting our matrix into row echelon form, now pivot elements means the first non-zero element in a row after applying row echelon form. We call it as pivot element. See, the first non-zero element in a row. This is the first non-zero element in a row. This is pivot. The first non-zero element in a row. This is pivot. The first non-zero element in a row. We call it as pivot element. So these are called pivot elements. So what's the use of this pivot element? That is very important to understand. We are going to discuss the use of pivot element in a minute. Before that, we do some practice examples to find the pivot elements. See, now the definition of the rank of a matrix means rank of a matrix is given as number of pivot elements. See, after applying row echelon form, how many pivot elements are there? 3 pivot elements are there. So the rank of this matrix is 3. We do some practice examples. Suppose you take an X matrix. After converting it into row echelon form, this is what we obtained. How many pivot elements are there in this? The first non-zero element is 1. This is pivot element. The first non-zero element in this row is 3. This is pivot element. The first non-zero element, there is no non-zero element. So how many pivot elements are there? 2 pivot elements are there. What is the rank of this matrix? 2. Similarly, take one more example. So take a matrix X. After applying row echelon form, this is what we obtained. 2, 4, 9, 11, 0, 5, 6, minus 1, 0, 0, 0, 3. How many pivot elements are there? The first non-zero element, we call it as pivot. The first non-zero element, we call it as pivot. The first non-zero element, we call it as pivot. So what's the rank of the matrix? Rank of the matrix is 3. How many pivot elements are there? 3 pivot elements are there. So this is how we find the rank of the matrix. Now try to understand what's the use of this pivot element and finding the rank of a matrix. This is very important. This is what the actual concept you need to understand. See, the pivot elements give number of independent vectors. The concept of independent vectors was discussed in our previous classes, dependent and independent vectors. Please watch the classes and come back here. We are not explaining what's meant by independent vectors. Pivot elements provide you independent vectors. Why? Why pivot elements are providing independent vectors? That is the point we need to understand. See, the same example, this example we are taking it here. After applying row echelon form, this is what we got it as. These are the vectors. What are the pivot elements? One is pivot element, minus 3 and minus 17. So how many pivot elements are there? 3 are there. So how many independent vectors are there? This is one independent vector, this is one independent vector, this is another independent vector. So total how many independent vectors are there? 3 independent vectors are there. How come we say that pivot elements are providing independent vectors? That point we need to understand. See, after applying this, this is the row, this is the vector we got. See, independent vectors means this is an independent vector. How come we say that this is an independent vector? By using this vector, we are unable to obtain this vector by using the previous one. Means you take this vector, you do some vector algebraic operations, means multiply with scalar, adding 2 vectors. This is what vector algebraic operations. By applying some scalar or some adding 2 vectors, if you got this vector, then this is dependent vector. But you need to understand, using this vector, we are unable to get this vector. Why we are unable to get this vector? Because the second term is 0. Whatever you do, you multiply with, you are not going to get -3. So that's why it is independent vector. Because using this, we cannot get this. Similarly, this is also independent vector. How come we say that this is independent vector? By using these previous 2 vectors, we are unable to get the third one. Means you do some scalar operations, adding to these 2 vectors, whatever the vector algebra operations you have done, you are unable to get this one. Why? Because these 2 terms are 0. Whatever you do, you keep on adding or multiply with some number. If these 2 are 0, after doing the vector algebraic operations, you are unable to get -17. So that's why pivot elements gives number of independent vectors. And one more important point you need to understand. So pivot elements are giving number of independent vectors. What we have known from our previous classes, independent vectors means, see, how many independent vectors are there? 3 independent vectors are there. Each vector is an 3-dimensional coordinate system. So what's the vector space? What's the vector space these 3 vectors are going to cover? These 3 vectors are going to span. Here we call them as columns. What's the space these 3 columns are going to span? 3 independent vectors are going to span a 3-dimensional coordinate system, coordinate space. These vectors are in 3-dimensional coordinate system, means using these 3 vectors, we are able to span the entire 3-dimensional coordinate system. These vector space, column space, already discussed in our previous classes. So pivot elements are giving 3 independent vectors. The number of independent vectors are going to provide you the column space. So this is the point you need to understand. Pivot elements give dimension of the column space. Here 3 independent vectors are there, so it is going to span 3-dimensional space. You try to understand here, the basics about this are already covered in our previous classes. So indirectly what we are going to get here is the rank of a matrix is going to give you the dimension of the column space. This is the point you need to understand. Hope you understand the concept of rank of a matrix and its uses. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest update.